Okie dokie. In this video, we are starting 5.1's WebAssign. Let's get into it. So they say determine whether the system has one and only one, infinitely many, or no solutions. So we're really just solving for X and Y using algebraic methods like substitution or elimination, whichever you prefer. I'll probably go more of the elimination route because that'll be more applicable to the future material in 5.2 and 5.3. So elimination route is the idea of like when you look at these variables xx and yy, you ask yourselves how can I add or subtract these two equations in order to cancel out the either the x terms or the y terms. And so what we're going to do is take this equation and we're going to add it to this equation. And when we do that, we'll have x plus 4x, and that'll give us 5x. And when we have negative 3y plus 3y, that's going to give us 0y. So we'll just have nothing there. And then we'll have negative 13 plus 23. And the difference of those is just 10. So we'll have 10. This will allow us to solve for x. And then if we just plug it back into one of the equations, we should be able to solve for y. So let's see, we do 2 minus 3y equals negative 13. We can subtract 2, divide by negative 3, and we get y equals 5. So basically the act of just like trying to solve for x and y helps you answer this question, because if we just found a single solution, then that just means there's one and only solution, and it is at 2, 5. We'll see the other examples, the other outcomes as we work through these, but yeah, that's how we're going about it. So excuse me. Number 2, how can we cancel an x? How can we cancel a y? Well, the easier one here is probably to do this nice trick of multiplying this equation by 2, and then we can add it to the previous equation. Okay, so we're going to try to do this in one fell swoop. So we're going to do 2x plus 2 times 3x. So 2x plus 6x would be 8x. Now this one, negative 4y plus 2 times 2y. So that was intentional. Negative 4y plus 4y would be 0y. So there's no y term. And then negative 18 plus 2 times 5. So negative 18 plus 10. So that's negative 8. And then we have this equation. We divide by 8. We get negative 1. So far, so good. We see that we get a specific x value. So likely there's only one solution. Let's plug it back in. Let's plug it back in here to solve for y. 3 times negative 1 plus 2y equals 5. And we get negative 3 plus 2y equals 5. We can add that 3 over. We get 8, divide by 2, we get 4. So we get one solution at negative 1, 4. Okay. Number 3, here we go. So one thing I'll say is, do you notice anything fun about these two equations? Well, there's a 3x and a 6x, and a negative 1y and a negative 2y. Interesting. So based on if there was a solution like x and y, you would think that the ratios holding true, like 3 to 6 and 1 to 2 being the same ratio, you would hope negative 2 to 8 would be the same ratio. You'd hope it's negative 2 and negative 4 or whatever, but it's not. So it's likely going to be no solution just visualizing that. But let's act like we're just solving for x and y and see what it ends up showing us. So what would I do? I'd literally probably just go the route of dividing this by a half, or multiplying the previous one by 2, whichever one works. Let's just start with that and just see what we get. So I'm just going to rewrite the first equation here. And then I'm going to have the second equation. So we'll get 3x minus y equals 4. Do you see the dilemma here? So we have the same thing equaling -2 and the same thing equaling 4. So this would conclude that -2 must equal 4, but that's impossible. So the idea is that there is no solution here because there's no x and y that can satisfy both of these equations simultaneously. It's just not happening. So that's it. So if there's no solution, you type no solution here. That's pretty much it. All right. Yo, I'm looking for Grady. Have you seen him? Grade's gone again? Where's he at? I can't find him anywhere. Grade. Hey, yo, Grade. Hey, Grade. Grade. Oh, there he is. Yo, there you are, Grade. Oh my gosh, you're through the roof. Dude. Grade. You're literally through the roof right now. Dude, I know. Grade. Grade. What the heck? How'd you get through the roof? Huh? How'd you get through? Grade. How'd you get through the roof? Payhip.com/BTMathTutor. I know. Bye.